video. Okay, I'm now recording, so if you ask questions, it might sound up on the video. So what we were talking about today, as the class completes the chart, is so far we've already discussed this formula for exponential growth or decay. Y equals A times B to the X. So A represents our initial amount, B represents our multiplier, and X represents the number of time periods. Now going back to the multiplier for a moment, if we had words like double or triple, we just plug in those numbers. But if we had a percentage, as in percent growth or percent decay, you take that percentage, which is your rate, and you either add it or subtract it from 1. You would add it if it were growth, subtract it if it were decay. So what that B, that multiplier ends up being, is if it's growth, B is greater than 1. And if it's decay, B is in between 0 and 1. So it's less than 1. In this example, for Alex buying a card, for $4, that's our initial amount. It increases by 40%, so our rate is 0.4. And because it's an increase to find our B, we would add that to 1. And so here you see every step. And this is the equation. So I could either give you the information and you give me the equation, or I could give you the equation and you could go, oh, the initial investment was $4, and it's a growth, because it's greater than 1, of 40%. Okay, so you guys tell me about this chart. What do we get for this chart? Oh, that was really quick. So 4, 5.6, and then what? 7.84. 10.9 what? 7.6, and then
13.3664.
15? Yeah. Okay. Alright, so these are our values. And then we could come down here and take this information in table form and turn it into a graph. So what we would put on our horizontal axis would be our independent variable, which in this case is time in years. And it looks like I need to go up to 4, so I could count 1, 2, 3, 4. And on the vertical axis, we will have our dependent variable, which in this case is value in terms of dollars. And we needed to go up to a little past 15, so if I started out with 2, 4, 6, 8, 10, 12, 14, 16, that ought to do it. So go ahead and finish plotting these points on this graph now. Okay, do you notice a little curve to that? Yeah, does look like a little curve. All right, let's come down here and answer some of these questions. It says identify the y-intercept of the graph. The y-intercept was the point 0, 4, wasn't it? And what does it represent in terms of our word problem? The y-intercept is always going to represent the initial, and in this case, investment. So whatever the initial amount was. Okay, 2b. What is the growth factor 1 plus r when written as a percent? So the growth factor would be 140% as a growth factor. It's 1.4 here, and that's what it's equal to as a percentage. Okay, it says to use the graph to estimate the card's value in 3.5 years. So let's think about this. If we want to come up to 3.5, there's not anything there.
We connect the graph.
Why would we? I like it.
It still has value in between the years.
Very good. Time is measured continuously, so it does have value in between all of these, so we would connect the dots. So to the best of your ability, draw in what looks like a nice curve to you. I'll do my best on the baby. Sometimes it's good, sometimes it's not. Alright, so now we can use this information to see about 3.5 years. So at 3.5 years, we're about right here. And so what would be the estimated value of the card? It would be about $12. And we did. You just explained why it makes sense to connect the dots. Time is a continuous measurement, and so this would be continuous. Okay, D says describe the domain and range of the function outside of the context of the problem. So if we're thinking outside of the context, this would be if I ask you to graph this equation on your last quiz, and all I did was gave you the equation, nothing else. You would say the domain is what? Yeah, negative infinity to positive infinity. Wasn't that the domain for every exponential function?
Oh.
And the range?
4.
Was it shifted up or down any?
No.
No, it would be from 0 to infinity. But in context of this problem, things change a little, don't they? Our domain. Does a negative time make any sense? No, a negative time doesn't make sense. The card had no value to us before we bought it. So our domain would go from 0 to, I don't know.
Not infinity.
Not infinity, because we don't live forever, do we?
I mean, the kids.
Until we sell the card?
Like 90 years. The card will live forever.
It could.
Not until it decomposes.
Or it could catch on fire one day. Or it could decompose.
It has
Or-
the ability.
So, all we can really say is it starts at 0. And we have information in this problem to where it went up to 4. So, all they gave us in this problem tells us it went up to 4. Now, if they gave us more information, if we're keeping the card for 25 years, then we could say from 0 to 25. So this is a little question mark.
Can we put a parenthesis to say like 4 and then?
That we're not sure. Okay. Range.
4 to 15, 4 to 15.
4 to 15 is all we have in this, right? So something like that. We might keep this card longer. All we have is what we have. All we have is the information we currently have. Okay, so this is growth, and it is increasing from left to right. And according to our graph, it increases forever, even though we talked about how forever really doesn't make sense when we're talking about a baseball card. Okay? All right, now flip on over to page 280, and we're going to investigate some exponential decay. I saw that. But your mom said your dad was okay.
Okay.
Fans too. Time to sign a new card. Yeah. Yep. Okay. Alright. So decay is that where the B is less than 1. So it ends up being between 0 and 1. Where our multiplier. So in this example, we're paying $12,000 for a card. The value depreciates. Well, doesn't that mean decreases? So anything that is decreasing is decay versus anything that is increasing by percent is growth. So this says it decreases at a rate of 15% per year. That is that the card loses 15% of its value each year. So if we went back to the standard form for this equation, it would be, what is the initial value of the card?
12,000.
12,000. And it is decreasing, so it's 1 minus your rate, written as a decimal, 0.15, to the t. In this case, t represents time in years.
What did it represent last time?
Time in years also. Okay, so if I gave you this problem, it could look like this. 12,000.85 to the t. So if I just gave you this without the words, how would you know it's decay?
Because it's less than 1.
Because it's less than 1. What is the rate of decay? If I just gave you this, how would you know? 0.15, because that's how far away this is from 1. That's the difference between this rate and 1. Okay, what was the initial price of the car? 12,000. So we could go either way. I could give you information and you give me the equation. I could give you the equation and you tell me about the information. Go ahead and complete the table and graph this. Okay, let's take a look at this. Hopefully you got nearly the same values. You may have even given me 2 decimal places. Did you give that? It said to the nearest dollar, but when we're talking about money, if you round it to the nearest cent, I'm always happy with that. Especially when we're going to get to some compounding interest, and we would always round our money to the nearest cent then. Okay, but this said to the nearest dollar, so if you gave me the nearest dollar, great. And when you graphed it, it'd kind of make this. Alright, so this y-intercept here is at 12,000. So that's the initial value of the car. The decay factor this factor is just something we're multiplying by. And so this is a factor and this is a factor because those are two things we're multiplying by. The decay factor is 0.85, but written as a percentage would be 85%. Does that make sense? Okay. Let's take a look at the other questions. Here we go, finally. And here's that graph where I've copied and pasted it. What values make sense for the domain and range of this function? Let's go in context. In context of this problem, the domain would be from 0 to 6 years. Does that make sense? And in context of this problem, the value of the car, that minimum value on here, whoops, I'm stealing it, 4526. The value of the car, the lowest value was 4,526 up to the price we paid for it, 12,000. So do these domains and ranges make sense in context of this problem? All right. Predict the value of the car after 10 years. Well, we have this equation. We have the value after a given amount of time is equal to that 12,000 times 0.85 to the t. And t represents time in years. So we would just plug in 10. And what would the value of the car be approximately? $2,362.50. Did you get 49 cents?
Yeah.
Okay.
Well, I rounded up. I rounded up.
You rounded up. Okay. I'd take 49 or 50. Okay, now this one. In how many years will the car you have a value of 8,000? Well, that's where I would need to draw in that horizontal at 8,000 and look down. So, to answer this, it looks like this intersection is just a little after 2 years. So, a little more than 2 years.
Why is the golf cart cost less than, why does the car cost less than the golf cart?
Why would a car cost less than a golf cart?
Yeah, is that like very unique car?
No.
$12,000 car.
No, probably my car right now is not worth $5,000.
It's like a jalopy.
It'll be close. My car is as old as my son, and he's not. So, I hope I get another 4 years out of it. 17, that sounds good.
You own it.
Mine only has 180,000. I'd like to go for 300.
Are you guys thinking?
All right,
We're gonna get a new car.
180,000 miles. Yeah. All right. Any questions about exponential decay and graphing and interpreting the graph? Good stuff. All right. Now let's take a look at some other types of problems we might see. The first one is going back to that y equals a times b to the x. A represents what, guys? Initial amount. The initial value, the initial amount. What does b represent? Your multiplier. What are you multiplying by? Not multiplier. Multiplier. Okay, and x represents the number of time periods. Now, if your time periods in your word problem all match, like if they're all in terms of years, you don't have to identify that x. But if part of it is talking about hours and another part is talking about minutes, you have to define what x means for you or what t means for you. Does t in your problem mean minutes or does t in your problem mean hours? Okay, so as long as they're all in the same unit, we're good. But if our unit of measurement is different and within the same problem, then you have to define what x is. Okay, our multiplier. So if it's growth, what we change that percent to a decimal, and do we add or subtract from 1? Add. So it's 1 plus the percent written as a decimal. If it's decay, it is 1 minus the percent written as a decimal. All right, example 1. Determine the value of an SUV after 5 years if the purchase price was $43,000 and it decreased in value by 5% per year. This is a nicer car. It's not decreasing in value as rapidly. So we have the value with respect to time is equal to, what's the initial value? 43,000. It is decay. So this is going to be 1 minus the 0.05. So it would be 0.95. So my decay factor is 0.95. What is 1 minus 0.05? Okay? And T. Well, in this case, this was in years, and this was in years. So T is going to represent time in years. Good. Because everything was in years. All right, so if we want to find the value after 5 years, all we do is plug in 5. And you tell me what that is. Let's see if you can punch it in.
Do you care? I just left it as 1 minus 0.05 in this parentheses. Does that matter?
33,272.
If I ask you what the decay factor is, you can go ahead and simplify that.
I just meant on like the normal equation.
Gotcha. Okay, so you got 33,000, which is good. $33,272 and 58 cents. So after 5 years, we went from we lost $10,000 in value. Yep. That actually isn't bad. A decay rate of 5% here is really not that bad. Most cars is higher than 5%. All right, you try. Determine the value of a house after 15 years, given a purchase price and an increasing value.
So it's on the water.
So it costs more? Or how does that work?
You could like put restorations in.
The value of the house increased. You guys probably aren't aware of that because the last couple of years the values of houses haven't increased well. But the first house I bought increased in value by $25,000 in 2 years, and I sold it for a good, $25,000 more than I paid for it. Now, my current house had gone up in value, one appraised, and then it bottomed out, and now it's slowly climbing back up.
So you can't stop.
I don't want to. I'm happy. I'm content. Except I wish it was closer to school.
How far away do you live?
Where do you live?
It's only 15 minutes.
That's not terrible.
It's not until your children are not old enough to drive and you're their little chauffeur after school every day and they're doing activities. So you get in the car, you drive home and you change and you go there and then you come back and you get the other one and then you go there and then you go back to the first place and then you come back and then you go. Yeah. Yeah. I'm in the chauffeuring age of motherhood.
My mom is too.
Is she? It's lovely.
I'll be out of that chance.
Alright. So this is the value of our house with respect to time. The initial value was $230,000. It is increasing, so it's 1 plus 0.035. Did you put the 0 in there?
No. Yeah.
Okay, to the T. And in this case, T is time in years. And it's not as important that I define it here because everything was in years, but it's good to define it. And now I want to know what the value would be after 15 years if we continued with that growth for 15 years.
380.
Isn't that nice? Your house would be worth approximately $330.23. $385 is correct. Thank you. Yeah. Okay. All right. We have tissue over here.
Smart to buy a house right now.
You got tissue over here.
Sell it.
There's no paper towels in the bathroom.
Or before the market.
I don't know. Or you just need to go. If there's something that does, we have one.
There we go.
We didn't even know how much more, so maybe that's why I started first.
Alright, number 2. A dye is injected into a pancreas during a certain medical procedure. The physician injects 0.3 grams of dye into the healthy pancreas, and it will secrete 4% of the dye each minute. Predict the amount of dye remaining to the nearest thousandth of a gram in a healthy pancreas 30 minutes after the injection. So we're in minutes and minutes, so our time will be time in minutes. So the amount remaining after a given time is equal to the initial amount, which is 0.3 grams. It's secreting. Is that increasing or decreasing?
Decreasing.
Decreasing, so it's 1 minus 0.04 to the t, and t is going to represent time in minutes.
Wow, that's a lot of time.
Okay, so if I ask you what the decay factor is, you would say it's 0.96, right?
Oh, nice.
And we want to see after 30 minutes, so we plug in the 30 for our time. And so the amount remaining after 30 minutes is approximately, how much dye is left?
0.08.
Okay. So, if we had significantly more or less than this, that would tell us about our pancreas is functioning, wouldn't it? Okay. All right. You try the next one, and be careful.
It's half hour.
Half hour.
So would you have to like rub something?
So you have to be careful about what you let T represent.
You have to.
Oh, it has to be like half an hour.
Wait, so you multiply.
Take a think.
Would it be like times two? Take a think.
It'd be 180. Do you just multiply the 30 by 6? Yeah. When you do like the thing with so when you do like the thing with the fraction bar in the parentheses when you're like compounding. I don't know if we're doing that right now. But
We are. We're going to do
yeah.
that in a minute, and I'll explain all of that. It's on the other side of your note sheet. Okay, so the amount with respect to time is represented by the equation. 2 times 1 minus 0.065 to the t. Now I have to define t. As I wrote it, t represents each half hour. Time in 30-minute intervals. Okay, but what if I didn't want to do it that way? What if I wanted t to be time in hours instead?
Double it.
How? Yes, then it would be 2t. Because it happens twice an hour. Right? So, if I wanted this to be time in hours, it's 2t. Okay? What if this instead of a half hour, it said every 20 minutes? How many times does that happen an hour? 3t.
Wait, also, could you, instead of doing 6.5 each half hour, could you do 13 each
No.
hour?
No,
Would that not work?
that doesn't work.
Oh, because it's exponential.
Because of the exponential.
1.33.
Okay, so this would be 3 hours later. 2 times 0.935 to the 6th. Okay, and this would give us approximately
1.3.
1.34 grams.
3, 6.
Okay. I did not finish this. What's going to happen is tonight, there's going to be a 5-minute video for you to watch online about this. I'll put it on my YouTube, which means tomorrow you won't have a chance to watch it. But the answers to this will be in today's notes. Okay, so I'm going to keep recording. And I expect you to follow this to be able to finish up tomorrow's assignment.
Besides